Welcome, guys. I see.
Yes, sir.
All right. Hmm. What? Everybody don't wake up yet? I mean, it's
So
midday.
we just had a class actually just finished. Like we had
Oh,
presentations, yeah. So that's why we're a bit late.
oh, you have to switch over. I get
Yeah.
it. I get it. I know how it is.
Yes, sir. I'm withdrawing as well.
Okay. I wonder how it must be doing class hopping. It's from one Zoom meeting to another Zoom meeting.
Yeah, especially when you have back-to-back classes whole day. It's stressful.
Yeah.
Tiring.
Sir, it damages your
Yeah, I
eyes.
can imagine. I can imagine because and then another part of learning, is moving around, because when you're kind of stuck at your desk, you know, at least when you were going to the different classes, you're kind of running from one class to the next. So there's like a physical environmental change, so your brain can switch. But now you're in the same room and all that changes is the computer screen. So, anyway, guys. So has studio kick up into gear yet? Is that a yes?
Yes, so we actually have interim crit tomorrow and final crit next week.
I see. They're not wasting any
So,
time.
so I have a question for you in relation to that. So I am trying to do basically my presentation using Photoshop for interim, where I scan my sketches and I put them there on the sheet to do work out a layout for interim. However, when I scan my stuff and I put it in there, the image is looking very, very pixely. Only when I zoom in, it looks clean, but like when I pull out and look at the full page, the lines just looking very, I don't even know, chopped up. How can I fix that?
All right. We can look at it. Let's look at what we have to discuss today.
Okay.
I will insert an answer for you, hopefully in what we have to discuss today.
Okay. Thank you.
All right, cool. All right, guys. So welcome to another class. I see we have a bunch of persons here, so we can get going. All right. So today, so this week we're gonna move into doing vector images, vector editing in Illustrator. But that is for the practical class coming up. For our lecture class, though, we're going to finish up our whole discussion on image size, right? And I want to pose this question for you guys here. It is about image sizing. It also has a little bit to do with the question that you were asking a while ago. Okay, I'm gonna share my whiteboard. I'm just gonna share a screen rather than share the board so that we can kind of see where we are.
Excuse me, sir.
Mm-hmm.
Just before we move on, the activity from the last practical had to submit it, right?
Go again. The activity from the last one?
Practical, we had to
Right.
submit.
You're asking if you said if you are to submit it?
Yes, because when I went to submit it, it wasn't accepting, it says it wasn't accepting any uploads.
Oh, really? Oh.
Yes, and I emailed you, but you didn't respond, so.
Oh, my bad. To the DDM email?
Yes.
Okay, all right, hold on a second there. I don't know. I'll check out the timing and see. It's perhaps something to do with the timing. It says that that form is closed, right?
Yes,
Ah,
that's the link to the submit on the activity sheet, right?
yeah. All right, cool. All right, I'm gonna check it out. Student submissions, here we go. This is exercise 2. Hold on, exercise 2, you say?
Yes, so from last week, Wednesday.
Yeah, but I'm seeing submissions for it.
I'm not
Um,
sure. Looking for
Sir,
my
there was a
report.
point. There was a point in time where the submissions were. You were saying submissions no longer accepted. A lot of us tried to do it. However, later on, later on in the night, it was opened back. But I guess she
Oh,
wasn't notified that
Yes,
it was
sir.
opened back.
Remember,
oh, okay,
I was
okay,
the one
okay.
that came to your evening class
I
and
guess
let
she
you know
wasn't
that it
notified that
wasn't
it was.
working.
Oh, okay.
Okay, okay, okay. All right, cool. Right, because sometimes it's not enabled during class and I enable it afterwards. So, okay, just submit and put something in the chat, in the comment.
Okay, sir. Thank you.
All right. So how fitting that you guys coming up on final crit? Because my question that I'm posing for today's class activity, I would say is directly connected. The only difference is that, well, you won't be actually printing it. So you're not necessarily concerned with sheet size. Tell me something, do you guys still have to print for portfolio submission? What's the decision on that? Or not yet?
It's hand drawing, so I don't know about. So we have to draw it on the sheet.
But when oh, okay. But when you're putting stuff in your portfolio, like maybe putting together maybe your final project, I can't remember the name of your projects you have this semester, but I know them.
Yeah, but we so it will draw the drawings on the sheet, on the final sheet, to
Mhm.
scale, to size and everything, and that's what you will submit at the end of the semester.
Okay. Oh, so you
it's
don't do any
not
computer
digital.
generated
No, it's
content?
not. So I just wanted to do it on the computer for my layout for interim, for them to approve the layout before I actually start drawing on the final sheet. But no, it's not digital.
Okay. All right. All right. So we're gonna pick back up where we left off, right? And I think this will even connect to the question you were asking about displaying things on a screen. Okay, let's see here now. Let's go to share. There we go. Okay, so everybody can see my screen okay, right?
Yes, sir.
All right, so I have two devices on screen, right? Can't I go to full screen? F11. Okay. Full screen. There we go. Right. Okay. So I have two devices on screen, right? We have our printer and we have our computer monitor. Now, these are two devices that delivers images, well, to your eyes, so to speak, right? But they use two different technologies in which to do it, right? Well, I won't bother ask you because I'm going to ask you a bigger question later. But where's my video panel? Okay, here it is, right. The monitor, the technology that the monitor uses to display images to you is called pixels. And the technology that the printer uses to display images to you is called, anybody? Anybody knows this one?
So is it dots?
It is indeed dots. Now, in both cases, both of them display dots. It's just that one of them, the dots are like little lights that emit light, and the other one is actually like a speck of ink. But at the end of the day, both of these two technologies display images by using dots. Now, each of these technology has a maximum, or let's say a limit, to how much dots they can display. Most printers nowadays cannot display more than 300 dots. All right, so it's either 300 or less dots. Everybody got that?
Sir, that's like 200 dots per square inch or
Right. Sorry, per square inch. That's right. I should say that. That is the limit to how much of those little tiny dots it can squeeze into 1 inch and in 1 real world inch. Now, on the other hand, monitors nowadays, well, they're still kind of playing catch up. Maybe the most expensive monitor that you can buy. I mean, I have a, what size monitor is this? Like a 24-inch computer monitor. And what's it? I don't even remember the rating on it. I think it is 72. So most typical monitors you buy today will probably be 72. Some of them, mostly like the Apple, can go up to 96, but most of them struggle to go more than 100. So it can fit 72 dots in 1 inch. Right? Or maybe I'll just put 96, you know, for those of us that can afford it. But in this case, we can't say dots. We have to say pixels. Now, obviously, 300 dots is going to give you, is going to look sharper than 96 dots. But what happens is that the dots in the printer are, well, they're kind of very tiny. And they're even smaller than the dots on the monitor. So then what you find out is that the pixels on a monitor are more spread out than the dots that the printer gives it to you. So when you look at a photograph, like, you know, you get something like when you go to the photo studio and you print out a glamour shot and you look at it and it just looks sharp. That's because it can squeeze in 300 dots for every inch of that photo. Now, the truth is that your screen is doing the same thing. It's squeezing in pixels, but the pixels are like 2-3 times larger than the little tiny printer dots that you have. So it's spread out over a larger area. In a way, it's blurry, but because it's emitting light, and you're really talking about things that are like micrometers tiny. So at the end of the day, it still does look sharp. But this is just to highlight the two different ways of displaying technologies. And to this day, these are the only two ways known to man to display images. Either you're going to use pixels or you're going to use dots, right? There's no other way just yet. All right, good. Now I want to pose to you
Excuse me, sir.
a question. Did somebody ask a question? No?
Yes, sir.
Oh, yeah, your mic is low.
All right, sir, could you go back on the last slide you were on?
Yeah.
All right then, sir. So this is my question. For
Mhm.
example, when you're going to like plot a sheet on AutoCAD and the
Mhm.
default is like 300 per square inch, but
Mhm.
then when you print it,
Oh, when you print it, oh, it look like you get chip out. Oh boy. But I was actually coming to that in our question that we're going to do as a class activity. McLean, you had a question? No, hold on. No, McLean, you were talking.
yes, sir.
All right. You're saying when AutoCAD says 300 DPI,
But then when you print it, like on a platter, I'm wondering, does the conversion change or how does that go?
well, funny enough, but we're actually going to deal with that. The quickest way I can explain to you is that the printer driver does the conversion for you. But there is a little special thing that AutoCAD has that makes why AutoCAD drawings come out so sharp. And we're going to look into that.
Okay, sir.
We're going to look into that while we answer this question. So you are a CSA student preparing for your critique presentation. I did not collude with your lecturer. This just happens to be a question I ask usually. All right, just in case you wonder. So you design a sheet layout that has 3 items that you need to communicate. You plan to print your work on a 24 by 36 inch sheet. Now, the 3 items you want to communicate is a rendered image, a photograph of your site, and a plan from AutoCAD. So this will just drop right into your question, McLean. So using lessons from your lecture class on image size, determine the following. So the first thing we want to know is determine the best position on your sheet for the photograph and rendered image. Now this is your sheet. Oops, I'm moving that. This is your sheet right here, right? So let's imagine this is my sheet. It measures 24 by 36. Can I color this? No, can I just, so this don't get confused? Yeah, put this in gray. There we go. Well, no, you can't see it. But anyway, you get the idea. Let me get my marker here. Right. So this is the length of the sheet. 24. Sorry, 36, that should be, by 24 here. Now, oops. Based on the size of that sheet, you plan to put 3 items on that sheet. You want to put a picture here in this location, a picture or a render. You plan to have a plan here, maybe a site plan or something. And you either going to have a picture or a render in here as well. So these are the 3 items you want on your sheet. Now, this ties into the next topic we're going to look at the next couple of weeks, which is called framing and sheet layout. And what I've created here is really, we would call it a wireframe of your sheet layout, which means that you're determining the zones in which to position your drawings, right? Now, when you position the zones, I mean, each of these zones have sizes because at the end of the day, you know, you're working with a 36 by 24 sheet, right? So you're gonna print this sheet. Now, because you're gonna print this sheet, let me take this off. That means that the type of technology that you're gonna use to display the picture is the printer, right? And we know that the printer can give me a maximum of squeezing 300 dots in every inch. So we have that marked down already. Good. So we know that we're printing with the printer. Erase that. Oops. Let's go back over here now. Now, the question is asking you, should you put the rendered image that you generate in Lumion here in the bigger slot or in the smaller slot? Now, here is the important thing to determine. A photo, who determines the resolution of a photo? What determines the resolution of a photo? A picture that you take. You go on site to take a picture. What determines the resolution of that photo that you take? Anybody? That's a question I'm throwing out to you guys.
Sir, the size of this image sensor.
The what?
The size of the image sensor.
Nope, that's not it. That's not the answer. And it's just so ironic that your profile picture in Zoom has the actual answer to that question.
The crop factor.
The
crop.
what determines
The camera, sir.
exacto mundo? The camera.
But sir, that's the same thing to the image sensor, sir.
You said image sensor. Oh, sorry, I didn't hear you say sensor. Okay, but okay, wow. Well, in that case, then you just had to get super technical with your answer, right? Your image sensor. But anyway, let's just say the camera. So, right, so the camera is going to determine the limitation on the photo. Let me ask you this other question. I know some of us have not necessarily rendered images before or used Lumion before or any rendering program. But what do you think would limit how large a rendered image could be? Anybody can give me a guess?
The pixel resolution.
That's not quite the answer. Remember, you're trying to determine the best spot to put the photo. You already know that you're going to be limited with the resolution of your photo based on your camera. If the camera said it can only give you X, you can't get more from it. The only way to get more is to buy a new camera. However, for a rendered image, what determines how large you can go with the resolution for a rendered image? This is like you're using a rendering program and you're generating those nice renderings that you see all the time.
The pixel density, sir.
The
Pixel density.
Nope, not the answer.
Sir, wouldn't that be determined by you, sir? The person who's rendering the image?
You're getting warmer. One would almost, it's not a trick question, but that is pretty close to the answer. Because I guess in your head you're saying, but wait, you're not limited by any physical device, or are you? Any other answers to that question? What would limit how large you can render an image?
Program you're using, sir.
The size of the computer screen, sir.
No. Theodore, well, you're more lukewarm. You're not fully warm. The closest person was who said you?
Me, sir.
Right. Right. I mean, in a way, it's you that determine it. But guess what? We have limited time, so I can't throw the questions for too long, right? So the thing that determines how large your rendering can go is usually time. Did anybody see that one coming? So technically there is no limit, because if you want to wait 4 hours for this image to render, then you are your own limit. That's why I say you are close to the answer, but it's not quite you, it's really time. If anybody had said the specs of the computer, then I would give them a pass with that one too. Because, you know, maybe your computer don't have enough memory and all these things or whatever, but, you know, usually when you're rendering an image, depending on the program that you're using, there are many different programs, but a lot of the time it's just how long you're going to wait for this image. So right away, those are your two limitations. Now, in our scenario here, and I was modest in choosing this, you're trying to determine which one to put where. Now, you already know that you're not limited with render. You can render an image at any size. So potentially you're not limited. However, in this case, we're going to say that I'm going to use a Galaxy S8. That's not too new, but it's not too old. Anybody here have a S8? Anybody? No? You have something newer?
Sir, that kind of old, you know.
That kind of old, don't? So I chose this phone because it's not the newest phone. But, you know, let's say not everybody can have the most high-end phone. Now, based on what, when you go to your phone website or GSM Arena or one of these sites that give you specs about phones, it tells you that, well, your phone can do a maximum of 12 megapixels. Then you might see some other things like f1.7, and it have a 26 millimeter wide angle lens. Now, we went through megapixel last week, right? Anybody remember what megapixel is?
The size of the photo, sir. Or
Not quite.
it's the resolution. I don't remember the formulas.
Sir, is
You
it
don't
the
have to
size
remember,
of
you don't
each
have to remember the
pixel on
formula.
sensor?
Just what it is. Yeah, yeah.
Is it the size of each pixel on the sensor?
No, it's not the size of each pixel on the sensor. That's actually another value that they sometimes give you the specs of.
The amount of pixels that an image holds?
That's right on the money. The amount of pixels that are in the image. So it doesn't really give you the resolution of the camera. You know? It don't say, well, it's HD or whatever. What it says is, well, when you snap a picture, this camera can compact in this image 12 million pixels. At the end of the day, it's not going to have more than 12 million pixels. So that is simply saying how much pixels it packs into the image. The more pixels in the image, well, the sharper the image is, because you remember when we looked at our example last week, we zoomed into the image until we could actually see the pixels. So the more pixels is the sharper it's going to be. Now, just for reference, when you see f7, it's really talking about f-stops, which is basically the size of the aperture. And your aperture is kind of like, you know how you watch these movies and you zoom into somebody's eyeball and you can see the eyeball open up or close. So that's essentially the aperture on the camera. The more the aperture opens up, the more light can pass through, and the less is the less light. The more light pass through, the better it is at like low light images and all of those things. So the lower that number, is the bigger the aperture. So this phone has an aperture of 1.7. Now we don't have to worry too much about that, but at least we know that on average, if you take an example here, an aperture of 2.2, remember this is the higher the number is the smaller the iris. So if you look on these two images, you notice that one looks brighter than the other. And that's simply because even a Galaxy S7 with an aperture of 1.7, when you take this night shot, it almost look, you can see the shot is bright, much brighter than this other shot here with a smaller aperture. And the last value here is the lens. And what this is simply saying is, I don't know if, has anybody here have ever tried to take an image of your bathroom? I mean, you might be saying, you know, why would I want to take an image of a bathroom? But let's just say, I don't know, you're in real estate or something, and you're trying to show somebody what the bathroom look like. That's usually a very hard shot to take. Can anybody tell me why?
The
Anybody?
bathroom too small.
Exactly, it's too small. So it's hard for you to like step back far enough to take a good shot. So that's essentially what the lens is. So the lower the lens number, the more you're able to step back, zoom out to see more. The higher the number is, the closer you will see. So this Galaxy has a 26mm lens. So that's like in the mid-range, out in the mid-range. Now, to answer our question, this is what we care about. We want to know how much pixels are here. So we want to know, when we go on site, snap a picture with our phones, can that picture work in the larger slot? Or is that picture best for the smaller slot? Now we don't have to worry about the rendering, because we can just, you know, determine if we want to wait on whatever size for the rendering. But we don't know how that image will look when we put it on our sheet. I remember well, if you're printing a photo, maybe the printer going to charge you $700 for one sheet. So you want to get this right. So how can we go about answering this? So this is what I want you guys to work out for me, because I'm just going to remind you of the formula. Oh, here it is here. Essentially, all we need to know is the resolution of the image and the DPI, and that will give us the real size. But guess what? All we have from the phone is the megapixel. I mean, it doesn't tell us what the resolution is. So if a phone is 12 megapixel, how do we determine roughly what the resolution of this is? Anybody? Do you remember what megapixel is?
Yes, sir.
I'm only going to help you with just a piece of this question. So remember, if this is the picture that your phone takes and it says that it is 13 megapixels, then it is saying that, you know, is it 13 or 12? How much was this phone? Was 12? Yeah, it was 12, not 13. Okay, good. Let's zoom in here. All right. So let's change that to 12. All right. So all we know is that there are 12 million pixels. There are 12 million pixels inside this. And well, if we remember our maths from school, right? We know that we just need to Let's make this a little smaller. Y and X. Actually, this should be Y and that should be X. So if we multiply these, then we would get this value here. See who remember maths. If we multiply this value and this value, we get this, kind of like area. So how can we get these values from this number? Anybody? Come on, remember your maths.
So we can do a ratio kind of thing.
Not quite. Let me give you a clue. Do we have time for clues? What time is it? No, we don't have any time for clues. So I have to give you the answer. We just take the square root, right? And that will basically give us what X and Y would be. It's going to make it even, but you know, we can work with that. Right, guys? So if we take the square root of this, we can evenly get what X is and what Y is, right? Because remember, we multiplied X and Y to get that. So, you know, we just take the square root. It's like area. So anyway, now, if we take the square root, and this, I'm just showing you guys how to work backwards, because this is something that you are going to face. Most of us only have our phones. And if we're going to take a picture to put on our sheet, we need to know if the picture can work or not, and not print it and then realize that the picture is so blurry. Remember, you know, go back here. On your screen can only display a maximum of 72 pixels. So that picture will always look sharp on your screen because your screen is not able to give you 300 dots, nowhere close to it. So when you look on that image at your screen, it's going to appear like it's sharp. But the problem is the output is not your screen, the output is printing. So anyway, if we work that out, anybody can give me the square root of 12 million? Remember, 12 megapixels. Come on. Nobody yet?
Hold on, sir.
3,464.
0.1.
Yeah, we can round it up. So this is saying that your camera is capable of taking an image that is 3,000 pixels by 3,000 pixels. That's all that is saying. All right. Now, chances are the specs of your phone probably tell you this already, maybe, but most times your cell phone don't really tell you the resolution. Sometimes it does say 12 megapixel. So this is like showing you guys how to work it backward. So if your phone said 12 megapixel, it could take an image that potentially is 3,400 pixels by 3,400 pixels. Now, right away, you have your resolution there. So you know that, okay, let's calculate the height. Just the height alone, because you need height and width because that gives you resolution. So we know that the height is 3,464 pixels. You had a question? All right, so now comes the question again. For those of you who remember, how do we determine the DPI? Anybody remember from last week?
I think I divided by 100, sir, or something. No, not 100. A different number.
But how did we get it? How did we come by that value?
So not what you're printing it for, like a billboard or something like that.
Exactly. Not quite the full answer, but I give you a half mark. So remember, the closer you are to an image is the more you will notice how blurry it is, right? And that is the key thing to remember when you're dealing with printing. Where is my, oh, it's behind here. Right. That is the key thing to realize when you're printing. The further you are away, the sharper the image will look, because it is smaller, because you're further away. The closer you are, the more you will notice how blurry it is. Now, this will determine what your DPI value is. So let me ask you guys a question. If this is the question that you're asking yourself, what type of presentation are you going to have? How far do you think, let's say the lecturers, the persons that, the audience, well, the audience that giving you a grade, how far do you think they will be from your sheet? Anybody?
Well, when we were doing face-to-face classes, it would be like 4 to 5 feet away.
All right, 4 to 5 feet. Anybody else had a different experience?
No, we've never had an experience.
No way, I know, right? It's so weird. Oh boy. All right, simulate. Simulate, you know, what it would be like. How far do you think, you know, the audience that matters, you know, the people who grade in your work, how far do you think? Don't try to get it exactly. Think about a range. Hmm?
Like a meter away.
Like a foot? All right, I hear a foot. Anybody else?
About 2 to 3 feet.
2 to 3 feet. All right, good. So I've gotten about 3 different answers, which is good. And this is why the reason that this is good is because the answer will always vary. So you would want to choose a value that is safe, but you don't want to choose a value that is ridiculous. You want to choose a reasonable value. Now, everybody, the closest answer I got was about a foot. So that goes to say that, you know, obviously they're not going to be directly in front of your sheet like this. And the other thing to remember is, remember the sheet is big. So if you are this close to a sheet, you're obviously not seeing the entire sheet. All right, so maybe 3 foot would be kind of the middle of what persons is suggesting. Now, I want to give you this chart here. And this chart kind of helps to help persons to determine how close, what DPI you need with certain distances, right? So if you are 3 feet away, 3 feet is about 1 meter. Then you don't need to work with a DPI higher than 180. Everybody follow that?
Yes, sir.
Now, remember, what is the maximum DPI that you can deliver? The maximum you can deliver is what your device allows you to. So your printer doesn't give you, well, maybe some printers, but most printers, chances are the platter that you're on.
No, it's I want my cousin the house.
The printer that you're on is can only give you a maximum of 300 DPI. However, you really don't need to use 300 because you're about a meter away. Some persons even said that maybe you would be 2 meters away. Is that 2 meters about 6 foot? So maybe in between. So you're definitely between 180 DPI and 90. So maybe a good middle ground between that would be about what? Let's do is a middle ground.
Sir, 150, sir.
About?
Or 150.
Yeah, all right. So call it
Yes,
about
I
150.
use-
So you realize you can almost use this as a standard and say, oh, well, if I'm printing for presentation, then the DPI that I need to work with don't need to be more than 150, maybe 180 if I want to be cautious, but definitely not less than 90. So all you need to do now is plug this value into your formula. All right, so if that is the case, then this is 150. So your camera can give you a maximum of 3,464. And based on the type of presentation you're having, you're going to work with 150 DPI. Then what is the real size that this camera will give you? That when you print, it will be 100% sharp. Anybody have that answer for me?
So that is 23.
20?
23, yeah. That's inches, right, sir?
Right. That's 23 inches. And then, I mean, well, in our case, the height and width is the same. So it would be 23. It would be 23 inches height and 23 inches width. I mean, if one was longer than the other, then it would, you just work out what it would be based on the resolution. All right, so let's look back here now. Now, when you look here, you realize that, well, wait, okay, so if I'm planning to put my image here in this zone that measure 14 by 20, and I'm going to be presenting where I'm about a foot, about 1 meter away, then I can easily put this picture here and it will not be blurry. Everybody see how we came to that answer?
Yes, sir. I understand.
Any questions? Nope, no so far.
No, sir.
All right, let me throw another one into the mix now. Now, earlier, I don't remember who asked me the question. Was it the question about if our output device is a screen, which is, I mean, that is our output device nowadays, right? If our output device is a screen, and that means that anybody who is looking on the image, well, let me not even put 96 as I said, because 96 is an expensive screen. Most of us don't have Apple monitors and all these things. So not, oops, 72. Now, let's do the same thing again. This time, you're not producing this to go on a printed paper, but instead you're producing this to be shown on a screen. You're going to email it to your lecturer, or you're going to show it through Zoom or whatever it is. You're going to show it on a computer screen. All right. So if that is the case, your phone gives you 3,464. But now, instead of using 150 DPI, because remember, the screen can't go more than what? Anybody? What's the maximum DPI of a screen?
72, sir.
Right, it's 72. Now think, The maximum DPI of the printer is 300. That means you can choose pretty much any value between 0 and 300. But the maximum PPI, not DPI, because your screen doesn't have dots, it has pixels. So the maximum amount of pixels that your screen can squash together is 72. So you don't even have a choice to use a higher value, even if you wanted to. So you would end up using 72, even if you would want it to be higher. Remember, your screen can't go more than 72 anyway. Then what you're going to notice you get now, so let me put this to one side. I want somebody to work this out for me. Print. What do we get for the height and the width? Anybody? Who worked this out?
So you get, hold on, sir.
48 inches.
Yeah, 48.
48 inches. All right, so compare these values now. What you notice? So basically what this is telling you is that whenever you're printing images, you need to have a higher amount of pixels. But whenever you're showing things on the screen, you really don't. So think about this. This is saying that the real world size of this image is now, remember, the real world size for it not to be blurry is 48 inches. Now, really and truly, that would mean that even if you had a older phone that could not go up to 3,000, if you had a phone that could only go up to, I don't know, 1,500 pixels, then it would still display sharp for you. But obviously, this would not work if you were printing. So the answer of when you're producing things for a screen, you don't need to worry about having to, you need better equipment when you're dealing with things for print. Let's put it that way. All right, so guys, so we worked out this one already. So we know that for here, if we were to print, if we were to be 3 feet away from the sheet, this little old phone would be good enough to take a picture of our site and put it at this large image here. Now, I'm going to leave you guys to answer this question here, which is, what resolution then should you render at? Now remember, when you render on Lumion, let's say you're using Lumion, you don't really have a limit, all you're really worried about is time. But why would you want to wait 4 hours for an image that you never need such a large resolution for in the first place? You get what I'm saying?
Yes, sir.
Right.
Yes, sir.
It's like I'm saying here that where is it? If you were deciding, should I take my expensive S20 phone to go out and take a picture, or should I take my cheap, give me a cheap phone? I don't know. Bangers.
Huawei,
Right?
sir.
Should I take the cheap phone and take a photo? Well, if you're going to present on a screen, which is limited to only 72 DPI. Then look at this. When I use the expensive phone, it's not even the expensive one, but when I use the expensive phone, it's telling me that I'm getting a 48-inch size image, you know, but if, you know, look at where I've allocated for here, you know, so this is like, I'm getting an image that's twice this size because I'm displaying it on a screen. So it just goes to show that when you're displaying on a screen, you can get away with more, but you still need to know the size that will look blurry. Now, the truth is that when you're on a screen, you can literally just see if it's blurry or not. So this is why if you are presenting things like in Google Slides or anything like that, you don't have to run this formula because what you see is what you get. But when you're printing, what you see is not what you get because the output is on another device that pack the dots closer together. But for most of us, even your cell phone, most devices can't pack more than 72 dots in every inch. Now, if your lecturer, for example, now had a device that have 150 dots per square inch, then when you give me that image, it may look blurry to me. But luckily for screens, we don't reach that technology yet. I mean, you have 100 PPI screens that's available now, but most of us just doesn't have that, you know? Anyway, all right, good. So where I leave you with, and we'll continue with this in our next lecture, is when we talk about file size. So the last part of our questions would say, what file type should I save my drawing in from AutoCAD? And funny enough, this was a question that was being asked. So you see, I was planning for you even before you asked the question. And, you know, there are so many different file types. Does anybody spot a file type that they don't recognize here?
TIFF.
So TIFF is new to you. Anybody else?
It is so nice.
EPS,
EPS.
AI,
Mhm.
SVG,
Right.
RAW.
Yeah.
Right. So a lot of us maybe know about JPEG and GIF, and some of us know PNG. All of us should know PDF. We just get to know PSD because we did that last week. But notice that when you're saving files, they're normally divided into two categories. Either it is raster or vector. Now, what we're doing this week, last week we did raster, and we did that using this file format, PSD, and we use it with other files, JPEGs of the clouds and whatever. And we even saved a PNG image, which we tested, that we put in PowerPoint. This week now, we're going to investigate vector images. And then we'll be better able to answer this question. When we're producing a plan from AutoCAD, what file format should we save in? Right? And that is the question that we will answer next week. But for now, what I expect everybody to get from now, because we're going to leave this topic now, is how do we determine if an image is appropriate for print, even though we're not printing now, but you know, we will start to print. And I mean, think about it. I mean, presentations are online now, but in the life of an architect, you know, you still have to go somewhere, have presentation boards, and you guys have it more complicated because you're not just presenting like drawings, but you're presenting images and all kind of things. So this will definitely matter to you. Now, one final thing I want to leave you with, which one of the questions asks, what resolution should you be printing at? Now, we know what resolution is, but I want to introduce you to this very interesting chart, and there's a link to it here. By the way, guys, This is actually a digital whiteboard. So you can actually access this whiteboard via a link. I'll put it on the website. Because we're going to use this for the next 2 weeks or so. But whenever you're saving an image, you know that it has we know about, resolution. But I want you to take a look on this chart here. Oh, I can't zoom in anymore. Can you guys see the numbers? Now, what this chart is saying is every resolution that is produced, there are certain standards. Now, here's a standard that we're used to, full HD, or otherwise known as FHD. So according to this chart, full HD would be that size. Can you see that highlight?
Yes, sir.
And that is what? That is a file format called Full HD. Let me just put that there. There, right. So that is Full HD. Actually, no, sorry, that's not Full HD. Full HD is here. And that has an amount of pixels 1920 by 1080. $2K, we hear about 2K all the time. This movie is 2K, this game is 2K, this TV is 2K. Well, 2K means, let me correct to 2K. So the 2K standard is 2048 by 1080. But then we have some standards that are long forgotten, like VGA. Anybody ever heard of VGA?
Yes, sir.
Here is VGA. And VGA is 640 by 480 pixels. So you can imagine that's small. Now, the reason I'm saying this is because some programs and some televisions and some phones and some monitors that you buy, they all go by these standards. So whenever you see the term HD on a monitor, then you know, okay, HD is, let me show you one. What time is it now? It is, okay, we're basically beyond the time now. So HD, we can see HD is 1280 by 720. So if you go to buy a monitor and it says it's HD, then that means it's 1280 by 720. But if it says that it is full HD, then that means it's supposed to be 1920 by 1080. So this is why you need to know the terms. And when you go into Lumion and you go to render, you might see it ask you, what size you want to render at. HD, full HD, QHD, UHD. And usually they put the numbers, but these are what the standards are. And the standards come with different ratios. So notice, if you were doing a 2K image, look at how wide that image is. And you can compare that to if you were doing what's another one that you hear about? Compare that to a WXGA, which is a one that is not very common, which is this one. No, this one. That is it. Right. You have to watch these arrows. And then you can see that, where is my fill? No, that's type. Let me try and fill this for you. That is much different than that. Oops, there's a fill on that. There we go. So we can see that this is much wider. This is a much wider image. So if you were, for example, rendering something that has a wide landscape and you wanted to choose a standard resolution to go by, then you would choose this one here. Whereas you could work with this one, but it's more of the ratio is not so wide. But then you can see this has way more pixels than that. So anyway, that is just introducing you guys to standard sizes. And I introduced that to you because To answer this part of the question here that asks, after positioning your photo, the alternate shot will be used for your rendering. What resolution should you render the image generated from your rendering program? Choose your answer from the standards list. Here is our standards list here. So when you work out how much pixels you will need to fill this slot, then I want you to choose the closest standard to give your answer. All right, do you guys understand the question?
Just repeat one more time, sir.
So the question is saying, so after positioning your photo, remember, I already helped you guys work out number one to determine the best position for the photo, right? So we found out what's the maximum our Samsung phone can take, and we determined that it should be the larger picture. So the other smaller area now, you are to determine what resolution should you render at. All right. Remember, just because Lumion can render at 8K or 2K, you don't want to say 8K just because you're just choosing the highest thing and then wait 4 hours when you don't need 8K to begin with. So this is why I want you to determine what resolution should you render your image at. And the answer that you give me should be based on this chart, the standards chart here. So you would say, oh, well, sir, the answer would be XGA plus, or the answer would be QSXGA, right? These are all video standards that exist, but we have probably only heard about maybe HD, Full HD, 2K, 4K, 6K. Oops, sorry. Here we go. Right, and some of us even heard of 8K, which is down here. I mean, that's pretty much the largest format that's available now. Right, so these are all the standards, and it's a nice little chart that you can use. So I want you to give me your answer based on this chart. Now, if you give me an answer that is too big, then it is wrong. If you give me an answer that is too small, then it is also wrong. You need to give me the best fit. Now, it's not going to fit exactly, but it needs to fit within the region of this part in your sheet. All right. And then this question, the last question, we will answer that next class. What file format should be used to save your plan from AutoCAD? Here are the different formats. We'll answer that question next week. All right, so what I'm going to do, guys, is just like our previous exercise, I'm going to post this on the site, and you guys are going to just submit your answers via the form. All right. This link to this whiteboard, I will put the link to the whiteboard on the form itself. So you can zoom in and pan around and look at all the different things and answer the question, okay? You don't need to answer the last question here. That question, I want you, we will, next week, I'll leave you to answer that. But you just need to answer question 1 and question 2. I help you work out 1 already. So I'm going to erase the answer and you give me the answer. All right, guys, any questions before we leave?
Sir, how are we going to submit?
Form, via form. So you're going to look at, remember how you did the specs of the computer where you saw the form on the site and you submit your answers? So you're going to do the same thing. So look out for that form on the website. All right, guys? I will activate it after class.
All right, sir.
All right, so everybody's clear on the task? Okay, we went a little bit over, but we started a little late, so yeah. All right. Are there any questions going once? Going twice? And gone. All right, great. So I'll see you guys on Wednesday. Remember, on Wednesday, we're going to be using Illustrator. So please come with Illustrator ready to do the activity. All right.
Okay.
Yes, sir.
All right, guys, stay safe, and I'll see you next time.